tomorrow, but hopefully next time I come back I'll be able to stay longer. So I have this talk for you about Rust and Ruby put together. I like to joke that I now only work in programming languages that start with RU. Yesterday in Lithuania, somebody asked me, does that mean that you also want to start speaking Russian? Because that's also RU. So, but yes, so I used to do a lot of Ruby work, and I still maintain a couple of Ruby gems, and I love Ruby and always will. I have a Ruby tattooed on me, so Ruby is with me until I die. But my day job is now working on the Rust programming language at Mozilla, and I really, really love Rust, and what's cool is you can use them together. So this is sort of a talk about there's sort of two parts. The first part is a little bit about Rust and what it's about and why you might want to consider using it, and then the second part is a really intense deep dive into a bunch of code about how to combine Ruby and Rust together. Also, my slides are unrendered Markdown in Vim, so you all know Markdown, so you can see. Okay, so in this first part, we're going to talk about three things. The first one is what is systems programming, because Rust describes itself as a systems programming language. The second one is a little bit about Rust itself, and then the third one is how Rust and Ruby make hard eyes emojis at each other. Okay, so systems programming. This is a term that means something different to almost everyone, it seems. I actually think that we might need to stop calling Rust a systems language, because when you say a systems programming language, people get very confused because they assume possibly the wrong thing. Yehuda has this definition of systems programming that I really like, which is when it actually matters. And what he means by that is we in the Ruby world like to say Ruby is slow sometimes, but that doesn't matter because the database is going to take longer than Ruby anyway. Ruby uses a lot of memory, but that doesn't matter because RAM is cheap. And that's completely true and very valid. I love Ruby for a number of reasons. But sometimes you're working on a problem where you can't use any more memory than necessary because maybe you're on a Raspberry Pi, for example, or something even smaller. Or maybe you need the speed because you're dealing with a 2 terabyte data set, and the difference between a slow program and a fast program is 1 day of processing time versus 1 week of processing time. So to me, systems programming is about being able to control all of these different aspects of things. And so that's what Rust lets you do. The other thing that I want to say about systems programming is that there's sort of this culture we have in the programming world of thinking that systems programming is lower level and therefore harder and therefore only for like good and better programmers. And I think that's totally not true. One thing that the reason this is not true is everybody is good at different stuff. We are different people. And so I know people who actually think that operating systems development is easier than Rails. They're like, assembly language does one thing, the command says exactly what it is, there can only be 1 or 2 arguments, and then it just works. Whereas you take one programming language and you generate a markup language and another programming language and a styling language, and you package them up and send them to a computer on the other side of the world, and you expect that to work somehow. That's too complicated. I'm going to go back to operating systems. Another thing that I really like about Rust is that we are very interested in helping people learn lower level programming specifically. And so if you've never done lower level stuff before, we are very, very interested in helping you out and welcoming you with open arms because low level programming is also really awesome. Another weird thing about Rust is that it is very low level, but it's also very high level at the same time. We'll see a little bit about that in a minute. Okay, so we like to say that Rust is a systems language focused on 3 things: safety, speed, and concurrency. I already told you about systems, but basically safety and speed are these 2 things that historically have been in tension in programming languages. So I have this little chart. On the left-hand side, you have speed, danger, and control. And that's sort of what C gives you. So C is very, very fast because you have control over exactly what's going on. But because you have exact control over what's going on, and humans are fallible, mistakes happen, and then bad things happen, basically. So it's very dangerous. Whereas a language like Ruby is designed for programmer happiness. Now, this doesn't mean that nothing can go wrong in Ruby, but certain kinds of things can't go wrong. So unless you're using a C extension, Ruby cannot segmentation fault, for example. So those kinds of problems are completely gone. Since you're not allocating memory yourself, you can't forget to free memory, and so memory leaks are much harder. But the downside of that is that it means Ruby is significantly slower than C because giving up that control is the safety that Ruby provides. And so languages are all over on the spectrum. I put Java in the middle because it's kind of in the middle, and there are definitely languages that are much slower than Ruby. So I don't mean that these are on the extreme ends of the spectrum, but this is sort of the way that a lot of people look at programming languages. And so the idea of Rust is to be as safe as Ruby, but to be as fast as C. And so if I tell you that there's something with no trade-offs, I'm definitely lying, right? Like nothing is perfect, so what's the catch? The catch is that the way that Rust does this safety and speed is by checking a lot of your code at compile time. So we just watched Piotr talk about, checking code smells. Rust checks a lot of things extremely strongly. And so the problem is that you get into this process, especially at the beginning, called, people like to say fighting with the compiler. I don't like to call it fighting with the compiler. I like to think of the compiler as a good friend of mine telling me I'm about to do something really stupid. Like, you're about to make a big mistake, please don't do that. And I'm like, okay, thank you. So to me, it's a much more friendly relationship than it is like a fist fight, but it makes people frustrated, and so they describe it as fighting with the compiler. What are you gonna do? That's the sweat smile emoji. The sweat drop is a little small on my font. I gotta get a better emoji font in Vim. And this is how it's fast, basically, because we do all this checking at compile time, so at runtime there's zero overhead. So you basically can generate the same assembly code that your C might, but we guarantee safety by checking stuff beforehand. Okay, so let's try some code. I'm going to show you a little bit of Rust stuff. So I have this file. I'm not going to actually use this one. Let's get rid of rubyconf LT, and let's make rubyconf by. So one of the interesting things about Rust is because I got involved very early, and then I managed to convince Yehuda to get involved, we sort of brought a lot of the Ruby experience to Rust. So cargo is basically bundler. Like, we paid Yehuda to write bundler in Rust. And by we, I mean Mozilla. And so to you crowd, it's not that interesting, but when I go to like other programming language conferences, they're like, whoa, this tool is really cool. But it's a little more boring at a Ruby conference. So what cargo new --bin does is it generates a cargo.toml file, which is basically your gem file, and then a source main.rs instead of lib.rb. Again, with the things almost being similar. Fun trivia fact, .rs is Serbia's top-level domain name. So like I own brooklyn.rs, which is kind of weird because it's like Brooklyn is in New York, not in Serbia, but whatever. Okay, so first I'm going to show you this cargo.toml file. We decided to go with toml instead of making it a DSL, basically just because toml is a pretty reasonable format. YAML is far too complicated, and nobody had written a YAML parser in Rust yet, so nobody wanted to write the YAML parser, but toml is much easier to parse, so we were able to write that very quickly. And so that's another big difference between Ruby. But basically the way toml works is you have this package directive, and then inside there's the name of the package, an initial version, which is 0.1.0, and then it picks up your authors from Git. So it read my Git information and put that there. And then there's this dependencies section. So this is very familiar to you. If you want to depend on libc, for example, you could say libc 0.12.0 or whatever, and then it will pull down the dependency and build it. It's bundler. You already know this. Okay, now I'm going to show you Rust automatically generates a hello world program, and this is important because I think I'm legally required to show you hello world first in a new programming language, or the programming language police will come get me. So Rust Hello World has a little more ceremony than Ruby's does, but not too much. The first thing you'll notice is that we have a main function here. So instead of executing just all the code in the file like Ruby does, Rust will call your main function first. And we used fn as the keyword for function because function is far too long. When I'm talking to JavaScript people, I usually make a joke about how we learned from their mistakes. Typing function is too far. And then somebody said, what about fun? And I was like, that's kind of cute, but like, I don't know, it's a little maybe too cute. And somebody said funk, but that's like, it sounds like funk with a K instead of funk with a C, and that smells, so like, I don't know. So we went with fn. And then finally, println hello world is basically the same as puts. One thing that's very different from Ruby and Rust, though, is the bang. So the bang does not mean dangerous like it means in Ruby. In this case, it means we're calling a macro. So Rust has a macro system that lets you do all kinds of interesting things. I'll run hello world before I'll show you that kind of thing. So you can do cargo run, which is just like bundle exec, whatever. And it will compile your project and then run it, so we get hello world. So what the macro system can do is, for example, say I want to interpolate the value 5 in the string. I love live coding because I'm going to make so many mistakes. Get ready to watch me be terrible at Vim. So the little pinchers are sort of like in Ruby, but you need the hash sign in Ruby, so it's almost the same but a little different. That's where the 5 will be interpolated. And so if we run this, this now says hello world 5. But what's cool about macros is, and compilers is that say we had this interpolated value here, but we forgot to pass it an argument. What Rust will do is it will say, hey, there's a problem here, and it will say there's an invalid reference to the 0th argument because no arguments were actually given. So Rust can actually check your format strings at compile time and double check that they're correct, and that's sort of what this macro system does. I mean, among other things, that's what it does for println. It's not like we made a macro system just to check format arguments. And then another thing that I really like, I'm going to get rid of this so that this actually just prints out, is that in Rust we don't have classes, we have structs and implementations. So if I wanted to make, say, a point struct, so maybe I have this point, and it's got an x and a y coordinate with 32-bit integers. So Rust is strongly statically typed, so you need to put in type declarations. But it also does some amount of inference, so you don't have to always put them in. But this is just the data, no behavior. And so you could use this struct and make a new one, for example. So use the let keyword to introduce a new variable, and the origin is equal to the point with x and y being 0. So this is just data. However, and this will compile and still just print hello world, and you get warnings. So we have some style warning stuff in the compiler already, and it's like, hey, you never used x and y, because we are a statically typed language, so we can tell that you've never used these things. But then if you want to add a method onto the struct, you can do that with impl. So impl point, if I can spell correctly. So I'm going to call this, I'm just going to say edit. I accidentally named it move yesterday, and I forgot move was a keyword in Rust, so it didn't work. So I didn't come up with a better name until just now, so whatever, it's going to be edit. So here's what a method looks like in Rust. So there's this impl block, and then inside the impl block you write functions, sort of like you wrote the function main there. But the difference is that we don't have an implicit self, we have an explicit self. So in this case, also everything is immutable by default in Rust. So we have to say, okay, this is a mutable reference to myself. And then you can edit, the x and y points on self, and this method will now work. And this will now compile, and it doesn't actually print anything out. Printing it out is actually slightly complicated, and I'm just going to do it and not really explain a whole lot about it because I can, and I have better things to show you. But basically, Rust does not know how to print out any structure until you tell it, and one way to tell it is to say, hey, just give me the basic thing. And so that's what this derived debug does, and now it will print out, you can see the point move to 1, 2, so we've edited our struct. So you can see that some stuff feels kind of Ruby-like, other stuff doesn't feel very Ruby-like. There are many more features in Rust, and this is not really just an intro to Rust talk. It takes much more than 40 minutes to learn a programming language. So now I'm just going to not talk about Rust syntax anymore and dive into Ruby really deeply to talk about how you can combine Ruby and Rust together. There's a little more space. So I have this directory, and inside it I have 4 different examples of combining Ruby and Rust together to show you. Now, I'm going to show you the hardest and most complicated one first, and then go to the easy one. So that way you can like see what the library does for you, and then see how nice it is. So you're about to see a whole bunch of really scary, gross stuff. So it's better than that. Seriously, wait to the end. The way that we make a Ruby gem, so basically the first one that we're going to do is we're going to make a Ruby gem in Rust. So I have some Rust source code here, and well, because there's a compiled output, but you can see it has the same source lib.rs file. So if we go into source lib.rs, there's a whole bunch of junk in here. I'm going to remove these comments because we're not talking about comments right now. These are some Rust functions that pretend to be C functions. So fundamentally, the way that Rust and Ruby play together is that Ruby knows how to call into C, and Rust can sort of pretend to be C. And so Ruby doesn't know any better, and so everything just works. But in order to make Rust pretend to be C, we need to add extra annotations to make that happen. So here you'll notice this has nomangle pub extern C function hello Rust instead of just function hello Rust. And the nomangle and the nomangle and extern C basically says make this a C function, not a Rust function. Basically, there's this thing called an ABI, not an API, so application binary interface, and that is a specification that says how the assembly code is supposed to call a function. So C has a very well-defined way to call C functions in assembly. So Rust will generate this function in assembly the way C expects to be called, and that's basically how it works. In this case, we're returning a string hello world and just a reference to it. And then this fill slice method takes in a buffer and then copies the hello world into that buffer. This is slightly more complicated Rust code, but again, I'm not going to really go into it because it's not actually the point of the talk. And then I have this very simple function num that returns the number 5. So we're now going to go through a whole bunch of work to have Ruby code get at these two hello worlds and this 5 and print them out. That's basically going to be the end of it. And then finally, there's this crap at the bottom about personality and panic format. Those don't really matter all that much, and I'm not going to talk about them. Basically, panics are Rust's exception-like thing, and so if you have Rust code that throws an exception and it gets into Ruby, that doesn't work at all. Ruby will completely crash, and that's not Ruby's fault, that's your code's fault, and so basically this says just give an infinite loop if we try to throw an exception, basically. And then finally, there's this Rust example init function that's empty. I will show you why that matters in a second. Yeah, I really deleted the comments. It doesn't matter. So when you compile the Rust code, it ends up being put into this target release directory, and then we get this librustexample.so on the end. If you're on a Mac, it gives you a .dylib instead, and that's a shared object file that is dynamically linked, and so you can use it in your Ruby code. The .a is a statically linked version, and we could use that too, but there's reasons that we're going to use them. It's fine. Not going to get into it. So here is this Ruby gem now. I just generated this Ruby gem with Bundler. So in it, it's got a, we're going to ignore this bin directory. That was an experiment. I'm not going to talk about that. So normally your gems have this lib directory with the name of the gem inside it, .rb, right? That's how gems work. And then also, of course, you have to have a version file to say what version the gem is. Native gems that have C extensions also have an ext directory, and inside there is where your C code goes, and that's how Ruby knows how to talk to C stuff. So if you ever installed some gems and it says building native extensions and ... and it sits there for a while, we're about to see how that works, basically. Oh no, 15 minutes remaining on my laptop battery. It says it's like half full. Look at that little thing up there. Whatever. Let's see if I can finish this before my laptop dies. If we look into the lib directory, the Rust example.rb has nothing in it other than just requiring these two things. And this is going to require the C code, basically. And then in the ext directory, there's a couple of interesting files. The first one is extconf.rb. extconf.rb is a special file that RubyGems runs whenever you install the gem. And basically what it does is it's supposed to generate, its extconf is configure the extension. So it's configuring the C extension. And almost all extconf.rb files use this mkmf library. It took me a while to figure out that mkmf stands for make makefile. So there you go. And we say that we have this library called Rust example. And, sorry. Whew. And it has a function called Rust example init. And that is the initialization function that happens. Ooh, man. Apparently I was at the bar too late last night. Rust example init is the function that initializes the library, so you have to tell it this is the function to call. And then there's this create makefile with this name. And what this generates is a makefile, and that looks like this. So 75%. Okay, so be glad you don't have to write that by hand, but that's what mkmf does. And it's frankly more complicated than it needs to be for a simple gem like this, but for something more complicated, those features matter. And so the issue is that the makefile knows how to build C code, but not how to build Rust code. So what did I do? I wrote a little C program that calls the Rust. So we have Ruby calling C and then C calling Rust, and the C thinks that the Rust is also C. I told you this was the complicated way first. Extern is the way in C that you say a function is coming from somewhere else. So there's this hello Rust function and fill slice and num. Those are the three functions I showed you that were defined in Rust. And then there's this function hello, which calls hello Rust and then prints out the value that it gets back and returns nil. Qnil is what you call nil in C when you're using Ruby stuff, basically. And then value, the return value is like a Ruby object, basically. So almost all Ruby functions return this value. Make hello does the same thing. It allocates a buffer of size 14. It calls this fill slice method, prints it out, and then frees that buffer. And then finally, number calls that num function to get that 5, and then calls int to fix to turn a C integer into a fix num. And then finally, down here, there's this function called init Rust example. This is a convention that Ruby uses where it calls the name capital I init underscore the name of your gem, and this is that initialization function that gets called when your library gets loaded. So in this case, what we do is we define a module called Rust example, and then we define a singleton method on that module called hello, and it calls the hello C function, and 0 means it takes 0 arguments, and then same thing with make hello and number. So this is like the same thing as writing this code in Ruby, but writing it in C instead using Ruby's C internals stuff. Okay, so after all that business, we have enough stuff that this will actually work. And so I actually wrote a makefile to do this. And so there we go. We get hello world, and 5. So this builds the Rust, copies it over, builds the gem, and then runs Ruby requiring my gem and executing, calling Rust example hello, make hello, and then puts the number. So we just did all that work just to like get a 5, basically. So that's fundamentally what these libraries tend to do. However, there's much easier ways to do it. And so I'm going to show you 2 easier ways, hopefully. So the next one is Rails. This is a Rails app that I found hard to name, so I just put another R in front of it, whatever, it's fine. So in this Rails app, you know how the lib directory is like the Ruby code you haven't put into a gem yet because you're lazy and it's not really part of your model, so you just kind of shove it in there? That's what I did. So there's a thing that comes in the Ruby standard library called fiddle, and fiddle is awesome. And what fiddle does is we can define this Rust example class and define a number function, and then call fiddle.dlopen and just point it directly at that SO file, and fiddle knows how to load it up. And then we can say, hey, fiddle, make me a function. It's going to be the num function from in that shared object that you loaded up, and it takes no arguments and returns an integer back. And this will do all that C mapping crap for you. And so then we call that function and return the value because Ruby returns everything that's the end. And so this is like way easier than all that giant pile of C that I showed you, basically. So this is like more realistically how it works. And Yehuda has been using Rust in production now for like 2 years. And this is basically how, when you gem install Skylight, his monitoring thing, what happens is it will actually grab the SO off of S3, put it on your server, and then use Fiddle to open it up. So realistically, this is how people tend to use Rust and Ruby together. However, even this is not as awesome as it could be. I'm going to show you 2 other libraries that have happened recently. The first one is mrusty, and the second one is Ruru. I guess I'll show you them in the other order instead. And basically what they work together, or rather mrusty works for mruby, and Ruru works with MRI. So let's do Ruru first. What is going on? Oh, right, I'm in the Rails thing. So basically, we can require that lib Rust example and then call the function and get the number back. Since my laptop is dying and I'm not going to make you wait while I plug it in, you could know this gets printed out if you run the Rails thing, whatever. Okay, so I cannot type. Okay, Ruru. So, in this case, we can say dependencies, and in this case, I'm using a path to my local copy of Ruru because yesterday in Lithuania, this demo failed, and it turns out that the author of Ruru was actually in the audience, and at the party, we figured out what it was, and basically, there was a bug where it worked on OS X, but did not work on Linux, and so we fixed it, and I sent him a pull request when I was sitting back there after I showed up this morning today, but he hasn't merged it and released a new version yet. That jerk, I sent him it 2 hours ago. No, he's a really cool guy. Obviously, that's ridiculous, right? So I have the bug fixed locally, but he's going to put it together. And that was a ton of fun working on that last night. So you depend on that library, and then, I can't type. This is a bunch more complicated Rust code, but basically extern crate is sort of like require. It says bring this library into scope, and then we use all of these things. And Ruru VM is actually MRI. It's the virtual machine. And then hash, fixnum, class, and like object are all Ruby's hash and fixnum classes. So here there's this function called pow3. And what this does is it basically loops over a bunch of numbers and then makes them to the third power and stores them in a hash. So we take the Ruby VM and we ask it to parse the arguments we're given. And then we take the first argument and we convert it to a fixnum and then to a 64-bit integer. And then we make a Ruby hash. So this is actually making a Ruby hash. It's not a Rust thing. And then loops through these numbers and stores in the hash the number and the number to the third power and then returns that hash. And then we make this function called initialize my app, and in it we define a new class called calculator, and then on the calculator we define the pow3 function calling this pow3 function in Rust. So you can also see this feels very Ruby-ish, right? There's a lambda where you get something and then you call methods on it, right? This is like our spec basically. One thing that bugs me about it though is that like this is the Ruby syntax, right? And so it's just a little different, and I didn't fix it before we finished the language. So, oh no, I have to live with my mistakes forever. So when I do these projects and I switch between Ruby and Rust all the time, I get it wrong and it doesn't work and it's bad. But so this is much, much nicer than dealing with all of that shenanigans with like making all the functions with the C types and doing all the converting to the C types and dealing with all that stuff. We can actually just make Ruby objects directly. And so then that is actually able to be called. So here's an example.rb, and we use Fiddle again, basically, to load up that shared object library, and then we take initialize my app, and when we call it, that will then define our calculator class. So then in Ruby, we just call calculator.new.pow3, and we have a full Ruby class written in Rust. So this is really, really neat, and I think that it's very exciting. I like that library so much better than doing the manual stuff. Although the Fiddle stuff could be a little easier from the Ruby side, so maybe I'll make a good way to do some of that. But that doesn't exist, so I can't show you it. So now mrusty. mrusty is a way to put mruby inside your Rust code. So we've been putting Rust inside of Ruby, but now this is putting Ruby inside your Rust. This is actually pretty common for statically typed languages. So for example, a lot of people put Lua inside of things. So if you want to have a little bit of dynamic scripting inside an app that's mostly static, this is very popular. And so mRuby is kind of designed for this purpose. And so I think that it's really, really cool. In this project, we depend on this particular version of mRusty, and I'm also enabling this optional feature. So you can make it without readline or with readline, but I need readline for my demo, so I'm turning it on. And then inside of our main.rs here, this time we say, hey, we want this mRusty crate, and then we use mRusty, and inside our main function, we make a new mRuby instance. So this actually spins up an mRuby VM. And then we have this container structure that stores a number. And then mRusty has a little bit of a different API than Ruru does. So here we use the mrClass macro to make a container class, and then use the def macro to define a function and pass a Rust lambda with that name. And so it actually generates all that function setup stuff for you. So I'm not really sure whether I like this approach better or the other approach better. This one feels a little bit more magical, but it also seems, it's like, if you squint or if you have bad eyesight, like if I took off my glasses, it kind of almost looks like Ruby a little bit with like the class and def is all in the right place and the block syntax. Like, I don't know, it's okay. Anyway, so we have this thing to make a new one and then to get the value, and then we define a file that has it in it so we can require it from Ruby. Another cool thing is that it actually has Minitest spec built in, so you can then inline write Minitest spec stuff and run the tests, which is cool. And then finally, mruby.run, so when we made that mruby VM, we can write Ruby in a string, pass it to the VM and say execute that, and it will execute it and give us the value back. So this is kind of the most basic way that you can like script your Rust code with Ruby inside of it, and then this will print out the value that's returned, which is just 3 in this case. But as part of that, you can require external Ruby files. So for example, I have this greeting.rb file, and this is just regular old Ruby code that prints out hello there. But I can then require that from inside of my Rust program string that's doing mruby. And so you could actually, you don't need to like program inside of literal strings inside of another language. You can like write normal files like a human being and just require them. And so then we get greeting.new to string and print out that value there. I commented out this first part because we're going to do that first. But so cargo run will now build this, and it prints 3 and hello there. So we like made an mruby interpreter and did all that work. That's really cool. But the last really neat thing, and this is why I need readline, is so we can make a REPL out of our mruby instance and then call REPL.start. And now we'll get 3 and hello there, but then we'll also get IRB. So I can actually just type any Ruby code in here, you know, class foo and foo.new, and like this is a full IRB now running inside my Rust program. So this is really awesome and neat. If you haven't seen mruby, you should definitely check it out. I think that it's a very exciting project in general, and I think that it's great for the future of Ruby. So those are all of the different demos I have for you right now. So I'm going to go back. I didn't change, oh, no. I forgot to change the name of the directory here. Sorry about that. Slide 7. Okay. So part of my pitch here is to tell you about Rust, and I really love Rust, but I also really love Ruby. And so one of the great things I really like about Rust is that it plays well with other languages. So I've given similar talks like this to Ruby, or to Ruby crowds, to Python and JavaScript crowds as well. And so I think that it's really awesome that you can use Rust with other languages. So I'm definitely not telling you to stop programming in Ruby, because Ruby is wonderful and amazing. But you might want to also try out Rust, and if you like it, you can make Ruby and Rust work together. And I think that that is super, super cool. So with that, that is everything I have for you. Thank you again so much for having me here, and yeah.
Thank you.
And you should not follow me on Twitter. Don't do it. It's bad.
Thank you, Steve. Any questions? Here we go.
You have mruby.run.
Yes.
And then unwrap. So how does Rust know the type of the variable?
Yeah, so the question was you had mruby.run and then unwrap. So, and how does Rust know the type of the variable that's coming back? I'm going to go back to that actually because that's it's easier when you have the code. Oh, I always try to type a Ruby example. I should just make a symlink already. Okay, so this is here. Basically, so unwrap, if run returns an error technically. So it can say like this may have succeeded or may have failed. So what unwrap does is it says throw an exception if there's a failure. So fundamentally first, that's what unwrap does is just like, I know this is going to succeed, so trust me. But how Rust knows the type is this result to i32.unwrap. So the object that comes back, Rust doesn't actually know. It's sort of a generic any object type. And then I can call the 232 method to convert it. And then unwrap again, because if it's not an i32, that would fail. And so I'm just unwrapping all the time, which is bad in real code because blowing up when something goes wrong is like, computers never work. So if they exploded every time something went wrong, we wouldn't have computers anymore. But when you're doing demos at conferences, it works better. Yeah.
More? No?
Sweet.
Yeah, here we go.
So, would you recommend to use Rust for like some tasks that should task with concurrency or other stuff?
Yeah.
So, which task Rust uses?
So the question is, what tasks is Rust best used for? So the first one is I would say that anything that needs to be low level. So for example, Dropbox started using Rust, and that's because they wanted to write a new file system to save the way that their files get stored on all their hard drives in their data centers. And so for that, you need a low level programming language, and so Rust works. But most of us in our Rails apps are not writing new file systems, so that's kind of bad. What I would say is that it's any time you need performance. So you mentioned concurrency. So Rust does not have a GIL, so it's very good at concurrency. And also, I didn't have the chance to show you this, but Rust can actually give you compile time errors about your concurrency problems. So I actually now feel a little weird when I do concurrency in Ruby because I don't know if it works or not until I run it, and then it works sometimes but doesn't work other times, right? Whereas Rust will actually fail to compile. Which is really cool. So yes, so there was a talk at PyCon last year where someone did an example of Python has a GIL, so it's bad at concurrency. Does it sound familiar to anyone? And I actually don't think that's totally true, but he wrote a Rust version of the function that used the threads instead and was like, watch how I can make all of my CPUs go instead of just one of my CPUs. So I would say concurrency is one of the things. I've wanted to write a rescue backend in Rust for a while, so you could write your rescue jobs in Rust, for example. And so I think that kind of stuff is more interesting as to where you might write Rust. If you decide you like Rust, you can use it for basically anything, but like where it truly shines is stuff that needs performance or is low level. Yeah, totally.
First one.
What browser do you use?
So, what browser do I use? This is a funny question. As a Mozilla employee, oh, that's interesting. I closed the laptop and didn't actually go away. I actually use Iceweasel because I'm on Debian. So I'm not even using like real Firefox, I'm using fake Firefox. But from what I'm told, Mozilla and Debian are gonna like make up soon, and then there's gonna be a real Firefox on Debian again, so maybe I will use real Firefox. I switch between Firefox and Chrome sometimes. I have Chromium installed on this computer too, but I just have a distrust of Google like being in charge of everything, so it's not even about working at Mozilla, it's about being anti-Google is why I tend not to use Chrome. But it is a good browser, and I think that the web was bad when we only had one browser, so I'm glad that there are multiple browsers now because it makes all of them better, right? So Firefox used to be really awesome, and then it got kind of slow, and then Chrome came out, and now it's getting fast again, right? So they play off of each other. But yeah, Iceweasel.
All right, thank you, Steve.
Thanks so much.
Yeah, we have one more talk here, so we're taking 2 minutes break again, and we'll be continuing.